Hi guys, this is not my usual type of video. I just want to talk a little bit about microcontrollers, and I also want to show you something else at the end. But this is a development board for AVR microcontrollers. This is something that I built quite a long time ago, probably 7-8 years ago. I was not able to find anything for AVR microcontrollers, so I built my own development board, and I built about 100 of these and sold to my friends usually at work. So this is quite old, and I don't want to talk about this, but I just want to let you know that at the time I was considering a lot of microcontrollers. I think I read more than 15 or 20 microcontrollers datasheet, and at the time this was the best value for money that you can find. It was the best microcontroller. Even the PIC was much more popular at the time. I didn't want to use it. This was much better. But what I want to tell you is that right now, if you want to start using some microcontrollers, this is not really the way to go with AVR or I think how they call it, Arduino or something like this, the development boards that are very popular. I know there's probably a lot of forums and help and everything, but my opinion is that 8-bit microcontrollers are quite obsolete, and I will tell you why in just a minute. Right now, this video is made in 2012, beginning of 2012, so if you watch this video later, it may not be actual, or it will be, maybe this will not be the best microcontroller at that time, but right now, I think this Cortex M3 microcontrollers are probably the best value for money right now. So what you see here, it's a development board for ST version of Cortex M3, and they have quite a large selection of microcontrollers based on Cortex M3 and Cortex M4, and this is one of the basic one, not the most basic one. I think the microcontroller is about $2 or something like that. But this development board cost, I think, just a bit over $10 at DigiKey or Musar or something like that. And you have, this is another 32-bit microcontroller. This is just used for the firmware and to program this microcontroller. So there's a proprietary ST firmware inside this one. But I think this one is even more powerful than this one. This one has 128K of flash and 8K of RAM. I think this one has 20K of RAM or something like that. But this entire board is just over $10. Which I think it's a really great value. And like I said, the microcontroller can be purchased for about $2 in low quantities, like one piece, or I think there will not be much saving if you go with 100 pieces, but it will probably be just under $2. But you can find Cortex M0 if you really want to save money on a project or something for, I think, even under $1. So there is no reason to use right now an 8-bit microcontroller, because this one has many advantages over this one, and this one doesn't have any advantages over this one, not even power consumption. You may think that if this is just an 8-bit microcontroller, will use less power, but they use older manufacturing technology. I think it's probably over 200 nanometer for this one, and so the power consumption it's worse than for this one. This particular one with I think with the software that with as an example uses only 20 milliamps or just under 20 milliamps, and it runs at full 24 megahertz. So this cannot compare with this one. I think this one, in the way I have it here, it's using something like 30 milliamps using the software example that I built to display an ADC value on the LCD. And this is just for the microcontroller, not the entire development board. And what are the differences between this one and this one, except for the performance? As you can imagine, a 32-bit microcontroller, it even runs faster. This one works at 24 megahertz and this one at I think 16 megahertz. I think you can find now AVR microcontrollers that works at higher frequency, but they are still 8-bit microcontrollers, so they use 8-bit instructions and data, so they could not compare with a 32-bit microcontroller in terms of performance. And if you want to get the same performance from this one as from the AVR, you will probably even reduce the power consumption even more. So for the same application, you may be using quarter of the power of this one, old one. So power consumption it's not an issue. And then what you get here, it's a 12-bit ADC. I think that, yes, there are 2 ADC in this one, and each has it's multiplexed to 8 pins, so you have 16 input pins for ADC, for 12-bit ADC, compared to only one ADC here with 8 inputs, 8 multiplexed inputs. And yeah, 10-bit it's less than 12-bit. It's just the resolution will be 4 times lower on this one, on the ADC channel. So if you want to make more precise analog measurement, this will be really great, and I will really use this feature. There is not much on this board. There are 2 LEDs. There is a 32 kilohertz clock, and this is the main clock. It's an 8 megahertz clock, and that's about all. I think there is not much on this board, but for $10 it's a really great value, since it's hard to solder SMD components. I think this is a 64 pin part, not sure. Yeah, I think it's 64 pin. So it's nice to have it on a board with standard headers, so you can use it to develop your application. And I will tell you more about this later. But now I want to show you, if you really need more power, this one it's even more powerful. It's also from ST, but it's a Cortex M4, and I think it runs at 160 something megahertz. Not sure. Anyway, it's way faster than this one. So if you really need the type of performance, you can get this. I think this board is under $20, maybe 18 or something like that, and also has a lot more peripherals on the board. You get an accelerometer. I think it's 3-axis accelerometer, and this one, it's an audio chip. I think it's a 24-bit audio DAC. So this is probably even better than my sound card in my computer. But I think it's just output, and also you get a digital microphone. So, and you get an USB. I think this it's OTG, not sure, so it can be used as host. Or and this one, is the programming, the USB for programming, and you have the same ST microcontroller here. It's a Cortex M3 like on the other one. I think it's a newer version of firmware, but not sure. I think it's a newer one. And what is missing here is the 32K for clock, but not sure you will need it on this one. It depends, and you can solder. I think, I'm not sure if other parts are missing or just they wanted to save I don't know, a few cents. Not sure why they did this, but anyway, so this is a much more powerful board, and you can use this for even for a web server. I forgot to mention that this has 1 megabyte of flash, so a lot of programming memory for programs. 1 megabyte, it's just insane, and has, I think, probably the most RAM out of all the microcontrollers that I know on the market. It has 192K of RAM internally, so this is really great. I like this. I will use it in a much more complex application later on, but I don't have now time for this one. And what I did with this one in the last few days, it's a bit hard for me. I just programmed before using assembler and never used C to program a microcontroller. So this first time I do this, so it was not that easy for me. But and I didn't find a good example on how to use this color LCD. This is 160 by 128 pixel graphical LCD, and I want to use this because this you can get very cheap. I think this was $15 with a PCB, but you can get it without a PCB quite a lot under $10, maybe even close to $5. So it's a really cheap display, and I wanted to learn how to use it. I don't think you will be able to see something on this one. Maybe. A bit darker in here. So the reflections from the window. I will push the reset button so you can see. As you can see, it's quite fast. I think it can display about 80,000 pixels per second, something like that from my test. This, in the way I run it now at 6 megahertz. The SPI, this is an SPI LCD, forgot to mention, I think. And I have the ADC one in here, you see. I made just a small oscilloscope. Of course, it doesn't have any trigger or anything like that, but I was just playing with the graphics, and I made this oscilloscope. And this is a lot of garbage here, because the screen is red because I was drawing some circles, and then the oscilloscope is after this. But this was just what I had last time in here. I can make the screen all black and just a green trace. And I think this is the first channel from the first ADC, something like that. Anyway, I need to build a library for ASCII character, or so to be able to write code and numbers on this display. Unfortunately, this one doesn't have a library of characters like this 2x16 LCD. So I need to do my own library and put it in inside a microcontroller. But I need to do this soon because I want to use this firstly for BMS, for battery management system for lithium ion batteries. So I need to have this done quite soon, and I will show you later what I was able to do. And, this another SPI LCD that I purchased. It's quite a low power chip on glass. I think this one is 128 by 32 pixels, and it's just black and white, so it is controlled a little bit different from the color one. And I did not test it right now, but you will need to solder some external components. You have some capacitors, and there are not that many, but it's a bit hard to do it because there are the pins are quite close to each other. Not sure, I think it's 1 millimeter or something like that. It's not the usual 2.5 millimeter like you have here. From the picture I was thinking that this is a standard 2.5 millimeter pin, but since it is not. So I didn't test this one, but I'll probably do it. I don't know. I'm not that excited about this because this one also cost about $10 like the color one, and I prefer that one. And I also had this web server. This uses the AVR, the Atmega 128, so I think it's close to the most performant one. I think there is an Atmega 256, or maybe there are even newer microcontrollers that I don't know about, but this has 4K of RAM, so you can imagine they need an external RAM. This is 32K, I think, of RAM in order to be able to build a web server. So you can do, and this board was I think $50 or something like that, and you can do a much better job with this one, with Cortex M4. It's cheaper and it has way better performance. You don't need the external SRAM. The power consumption will be much lower. I think this one at the maximum frequency used something like 60 or 80 milliamps, something like that. And I think this includes also the other peripherals that are here on the board. So this is quite low power consumption considering the performance. Okay, I should show you this one. Yeah, it works. See, this is just displaying the input on ADC1 in volt, but this software was done in assembler, and I don't know why I find assembler to be easier when you work with hardware than C. Of course, when you process a lot of numbers and stuff, then C will be easier, but when you work with hardware like displays and stuff, it's probably more intuitive to program in assembler. At least I find this to be the case. And I should, you remember I had these batteries reviewed. These are, come on, focused. This is A123 batteries. These are 1000 milliamps or 1100 milliamps cells. They are 18650 cells, but they are too small to build large banks of battery. They are really good batteries. I like them. They have great performance, but they are really too small to build anything large. So I decided to purchase a different and larger battery that I have here. I will show you. I purchased 10 of these batteries. You can see these are prismatic cells, so are flat and are in a type of plastic bag, probably with a metal insert or something like that. Not sure why, but they will be a bit hard to connect, so I need to find a good method to connect this, because I don't think I will use it for more than, I don't know, maybe 40 or 50 amps, but I just want to find a good way to connect this, because this is really thin metal, and I think one it's aluminum and the other one it's copper with some something on the outside. Not sure exactly what they used to cover the copper, but you cannot solder any of this using regular solder, so I will need to find something with screws or something like that to connect these batteries. And I just did a very fast discharge and charge of these batteries, and they seem to work really good. So they have the 20 amp hour capacity they are specifying, and I will probably do a review about this, but right now I'm busy with some others. I got this from China, and including shipping and taxes, it was something like $33 for this 64 watt hour battery, so about 50 cents per watt hour, which is, I think, a great value, considering that this battery can actually recharge for more than 3000 times. They should be really good value. You cannot find better batteries, I think, for this kind of money. And I hope to soon do a review about these batteries, and also I need to receive some GBS batteries. They are larger cells, 100 amp hour, a little bit different chemistry. They still are lithium iron, but they use manganese, and they should have something like half the cycle of these ones, but the advantage is that they are easier to connect. They have proper screw terminals and are easier to connect, and who knows, maybe they are as good as this one or close to it, but they cost about the same per watt hour, but just are easier to deal with because they are larger and they have proper screw terminals, so are easier to connect to each other. But yeah, I will see. I could not test for life cycle. This is hard to do. I will need to discharge this 3000 times, and of course destroy it during the process, but 3000 charge discharge cycles are a bit hard to do with this type of batteries. So I will just trust the specification. Hopefully they are right, but if they are, this will last for more than 10 years in a typical solar application where I want to use them. Okay, this is all. Sorry, this was not a proper video, but I will hope to soon make a review about these batteries, and that one will be a much better video. This was just I just wanted to let you know about these batteries, and that hopefully soon enough I will do a review. I just wait for the GBS batteries to come so I can compare them a little bit. Okay, thanks for watching the video, and bye.